In this video, we're going to build a relay circuit using a bulb and a switch. And we're going to start out by wiring up the low current side of the relay, or the coil side. I'm going to connect a positive wire to terminal 85 on the coil. And I'm going to go from terminal 86 to my switch, and then from my switch to ground. Alright, and this is the low current side of the circuit, and my suggestion, get this built first. At least you can make the relay click. You can hear it click, so you know that half of the circuit's right. Failed to mention that we are using 12 volts. All these relays are designed to run off of 12 volts. Alright, so now that we've got the control side, or the coil side, also the low current side wired up and working, and we can move on to the high current side. I'm going to take 12 volts, run it to terminal 30, another jumper wire, connect to terminal 87, from 87 to my light bulb, and from my light bulb to ground. And the light comes on. Okay, as far as measuring our voltage drops, okay, so measure the voltage drops along the control side, which would be measuring voltage drop from terminal 85 to 86. I've got my meter set up to measure DC volts, and the voltage drop from 85 to 86 should be our source voltage. Right, in this case, 11.6 is all we're getting out of this box. So on the relay coil, that's the load on that side of the circuit, so it's going to drop to 12 volts. Now if we do a voltage drop on our high current side, going from terminal 30 to terminal 87, we get 0. Very low, right? Because that's not a load. That side of the relay is a switch, so it shouldn't drop any voltage. That path, or that part of the circuit, the load is the light bulb, and it should drop source voltage 11.8. As far as measuring current, set my meter up to measure current. I know that the current is going to be below 300 milliamps, so I'll go ahead and put the meter in that position. If I want to measure current through the low current side, I disconnect my terminal from terminal 85, connect it to my meter, and then touch my meter lead to terminal 85. I get 122 milliamps. Okay. Another way I could do that is turn my switch off, and I could just jumper across the switch. I get 123 milliamps. Okay. Now on the high current side, or the bulb side of the relay, I can disconnect, and I've chose to disconnect from, let's see, terminal 30. Connect my lead to the alligator wire. And touch my lead to terminal 30. I get 67.7. This box isn't really capable of putting out a lot of current, so that's why the current of the bulb is not higher than the current of the coil. But in a normal situation, that load would be a much higher current load, something like a blower motor or AC clutch. Okay. So those are the two currents of the different branches in this parallel circuit, because a relay is basically a parallel circuit. Now, to get the current of the entire circuit, we're going to have to break the circuit in a place that's common to both the control side and the high current side. So what I'm going to do is pull my ground wire out of the power supply, put my spare wire in the ground there, and go from the wire I took out to the wire I put in there, and I get 180 milliamps. So that would be the current of the entire circuit. So that's I got about 60 milliamps on the bulb, 120 on the coil, add those together, and that's how we get our total. That's how we verify that what we're measuring is correct. Okay. And that is our relay circuit.